recording. There we go. All right, so we know that A is 10 from the major axis, B is 5 from the minor axis. We know the center, so we can write that. Now, if the major axis is vertical, that's up and down. So I'm going to put 100 under the Y. That needs to be equal to 1. And now if the B is 5, and I know that the minor axis is horizontal, then we put 25 under the X, and we got it. Graph and locate the foci for this one. So we know the center is negative 1, 3. Negative 1, 3. And then from the center, we're going to go right and left the square root of 2, which is 1 point something. So you can just estimate it. We're not going to get decimal values and make sure it's exact. It's not really necessary. Then we're going to go up and down the square root of 5, which is 2 point something. Let's call it right there. 1, 2. Let's call it about right there. I really want to avoid using calculators to get decimals just so we can be another millimeter more accurate. There's the ellipse. Be careful. If that's a plus on the test, that's an ellipse. If there's a minus in the middle, you're going to graph a hyperbola. Don't mix them up. Be careful. With the foci. So c squared is equal to a squared minus b squared. And the a on an ellipse is the bigger value. The a on a hyperbola is the one that goes along with the positive term. Now, a is the bigger one on an ellipse because we want to know the major axis and the minor axis. But anyway, when you subtract, just make sure you don't get a negative value. So it's 5 minus 2. C is equal to plus or minus square root of 3. So square root of 3 is 1 point something. So there's your focal points. And we went from the center up and down to find those focal points, which means we altered the y of the center to get those focal points. So negative 1, 3, plus or minus square root of 3. There's the focal. There's the foci. There we go. Any questions? Let's roll on then. Next slide, write the standard form of the ellipse. We're going to factor out a 49 out of the x's. X squared plus, that's a 2. 2x plus something. Plus 16 times y squared minus 4y plus something is equal to 671 plus something plus something. 2 divided by 2 is 1. 1 squared is 1. So we're going to add 49 to this side. 4 divided by 2 is 2. 2 squared is 4. So we're going to add 64 to this side. And let's get that total. And I did it last period. Let's see if it's still up here. Yeah, that ends up being 784, which happens to be 49 times 16. So 784. Well, that's 49 times x plus 1 squared plus 16 times y minus 2 squared equals 784. We're going to divide everything by 784. 784. And that's going to be x plus 1 squared over 16 plus y minus 2 squared over 49 is equal to 1. Now, again, it's nice that the denominators are perfect squares, but as you saw in the example before, it's not really all that necessary to be perfect squares. We'll just kind of estimate where to put the values. And I'll look for accuracy between the integers, of course. So if you had, if this was a 47 and you put it at 7 point something, then I'm, of course, going to take off for that. But we want to be somewhat accurate. But as long as you're in between the integers, I'm okay with that. Write the equation of the hyperbola. Now we're going from ellipses to hyperbolas. All they do is give me points. So I think I'm going to plot this to see what's going on. 1, 2, 3, 4. And it doesn't even have to be this fancy, but we'll make it somewhat fancy. That's the center. The focus is 4, 5, 6, 7. 7, negative 2. So there's vertex, there's the focus. And, oh no, that's the center. Excuse me, that's the center. I knew that was wrong as soon as I said it. Vertex is 1, 2, 3, 4, 5, 6, -2. That's the vertex there. Now that tells us a lot. And this is opening to the right, this hyperbola. It's going towards the focus. So now let's get, they tell us the center. Now, because this is opening right and left, the x is first. So x minus 4 squared over something minus y plus 2 squared over something is equal to 1. Now, the distance from the center to the vertex, that's the a, and it happens to be 2 units. So under the x, because it's going right and left, we're going to put 4 under there. The distance from, no, 4 to 7, isn't it 4? 5, 5, 6, yeah, to the vertex. Okay, we're good. 2. C, center to focus, is 1, 2, 3 units. So c squared is equal to a squared plus b squared. So we're going to minus the 4 over. That's 5. So 5 goes under the y. Any questions on that? In exercises 43 to 50, convert each equation to standard form by completing the square on x and y. Then graph the hyperbola, locate the foci, and find the equations of the asymptotes. So let's factor out a 9 out of the x's. X squared minus 4x plus something minus 16 times y squared. Ooh, we got to be careful. I'm factoring a negative 16 out of negative 64. So that's going to be plus 4y plus something is equal to negative 116 plus something minus something. And if you ask sixth period, if I forgot to put a plus there, and if they tell you I did forget, they're liars. They're totally lying. I totally didn't forget to do that last period. Okay, I did. You got to be careful with these negatives. Last period, I went too fast, and I left that as a negative, and that's so easy to do. Yeah, I messed it up, but I didn't this time. So 4 divided by 2 is 2. 2 squared is 4. So that means we're adding 36 to that side. No, let's see. 4 divided by 2 is 2. 2 squared is 4. And so we're subtracting 64. So if we take negative, well, it's right here. Negative 116 plus 36 minus 64, that ends up being negative 144. Now, because that's negative, it's going to, of course, switch which one's positive, which one's negative here. So we have 9 times x minus 2 squared minus 16 times y plus 2 squared. And we're going to divide by negative 144. Divide by negative 144. Divide by negative 144. Oh, let's put the positive one first. We have y plus 2 squared over 9 minus x minus 2 squared over 16 is equal to 1. Well, now we have everything we need. We got the center, we got the a squared, the b squared. So the center is 2, negative 2. So be careful that you keep the x coordinate with the x coordinate, the y coordinate with the y coordinate. So don't mix them up just because you see this one first. I have made that mistake before, but I don't think I've done it this year yet. 2, negative 2. These are nice, perfect squares. That's great. No problem. Up and down 3. And right and left 4. 1, 2, 3, 4. This is not an ellipse. This is a hyperbola. I know that because there is a minus in the middle. So do not draw an ellipse. It's easy to do that because they start out the exact same way. So we're going to draw this rectangle. draw the asymptotes, and they're the diagonals of the rectangle, but we extend them out. They're asymptotes. And now we decide, well, how are we going to graph this? Well, y is the positive term, and we usually list that first, which means that this hyperbola is going to go up and down, like this right here, up and down. So the vertices are up and down, like that. And now we have a little bit more information that they want. They want the focal points. So let's go with foci. C squared is equal to a squared plus b squared. Now, a on a hyperbola is the first one. That's a squared right there. It doesn't have to be the bigger one because we're not talking about major and minor axes like we do with ellipses. Ellipses, a is the bigger one because that it goes along with the major axis. Here, the a goes along with the transverse axis. That's what determines a, and that's going to go along with the positive term. Anyway, we got c squared is equal to 25. So c is equal to plus or minus 5. So we're going up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5 right there. So if it's integers and not a square root, well, then I actually want the points. And that'll be easy. 2, 3, and the other point would be 2, negative 7. I don't want to see this. I don't want to see 2 and 3 plus or minus 5 like we do with radicals. Don't leave it like that because we actually have some nice points now. All right, finally, we have asymptotes. Both asymptotes will always go through the center. So we're going to use the point 2, negative 2. And then the other thing we need for a line is the slope. You need a point the line goes through, and you need a slope. And we do that a lot in calculus, believe it or not. 1, 2, 3, 1, 2, 3, 4. So we do old-fashioned slope, rise over run, 3/4. And then the other one would be 3, negative 4. So you can sum it up, both of the equations, by writing plus or minus 3/4. So the equation of the lines is y plus 2, because we're taking this to an opposite, is equal to plus or minus 3/4, then x minus 2. So that's the equation of both. No reason to put them in slope-intercept form other than if you saw a multiple choice question that went ahead and got them into slope-intercept form. Otherwise, this is a perfectly good form of a line. No problem there. You can just leave it. All right, that's what I got for you today. There's an assignment on your online book. It's titled 9.1 and 9.2 Review. So get that done. Make sure you're uploading these to Google Classroom with the exception of the one today. You're just going to do that online. And 9.3 is the Edpuzzle videos up. I got to get the notes on the schedule and a couple other things like the assignment and that. But if you want to watch the video and take some notes, when we're done here, I'm going to get those notes on my schedule, and you're good to go and continue on. And